Hello everyone, welcome back to another video. So this time I'm going to take you through for a visualization library. So this is one of the Python library where we can plot some beautiful graphs. So Matplotlib, we are going to talk about Matplot library. So which is a very powerful tool for data visualization. So and is widely used in scientific computing, engineering, and other fields. So it is also a popular choice for teaching data visualization concepts. So this is like a first step into the visualization. So we do have other visualization libraries in Python like Seaborn, Plotly. So those are like advanced. So if I wanted to step into the visualization thing, then this is my first step where you can plot simple line chart, bar chart. So I'm going to explain each and every graph. So with some basic concepts. So this is the first step into visualization. And okay, so here is a and why this is a powerful tool, Matplot library in Python, because it is open source and freely available, and it is widely used in scientific computing and engineering fields. So it is a popular choice for teaching data visualization concepts just because of it is uh, like freely available nature, and also we have a separate website for this Matplotlib where you can go and research whenever you wanted something. Then you can go there and you can research something, and you'll be able to find it on your own. Okay, and so the mainly the why do we need a visualization part over the normal data table, something like that? Because everything, whenever we are representing any data visually, the visual representation will give us a good clarity and also pattern recognition, storytelling, uh, and also the communication efficiency. So for example, if I look at the tabular data or raw data, I'm not able to understand it in a faster way. So, but in the same data, if I present it in a graph or in a visualization by using a visualization tool with some graphs, then I can able to grasp it very quickly. So that is effective communication in an efficient manner. And also we can able to do some decision making by looking at those graphs. So that is what it will do, this visualization things. And also we'll be able to explore the data quickly and also in an efficient manner. So that is a brief introduction about Matplot library. So let me start the session by importing some basic libraries. So I'm going to import matplotlib.pyplot as a PLT. So alias name is PLT, and then I also imported a NumPy, and also I imported pandas as PD. So let me run this. I'm going to start a session with a basic line chart. And also, when do we use this basic line chart? I'm going to cover a few charts like line chart, bar chart, pie chart. There are different kinds of charts, and depending on the requirement, when do we use those particular graphs? I'm also going to explain when do we use it. So I have a different categorical data, or I have data with only two variables. So what is the right choice, or what is the right graph to be selected? So let's start with the basic line chart. So here I'm just giving x is equal to np dot length space 0, 10, and 100, which will give me 0 to 10. Between 0 to 10, it will give me 100 points. So I just want 100 points from 0 to 10, like 0, 0.5, 0.25, 0.75, then 0.85, something like that. But I wanted 100 points in between 0 to 10. So this linspace command, it will generate the required numbers based on the conditions we pass. So here I am passing, I'm just telling her that I want 100 numbers from 0 to 10. So first number is starting number, then the second number is ending point, starting point, ending point, and how many intervals you wanted. Here I wanted 100 intervals. So that is the reason why np dot linspace 0 starting point, ending point, then the number of intervals I wanted. So this is my x variable, and also I'm passing a y variable is equal to np dot sin x, which is like whatever the numbers are generating here, I'm passing to a sine variable. So np dot sine. So these are my x and y. Then I wanted to plot x and y, a line chart between x and y. So let me run this. And also now I wanted to plot by using these two variables. So the syntax is like plt dot plot, and you need to pass the two variables. So now I wanted to plot x and y. My x-axis is with the numbers from 0 to 10 with 100 intervals, and my y-axis I want a sine wave. And I am giving you, if I wanted to title the graph, so you need to use the syntax plt dot title, then pass the comment whichever you wanted. So I just typed basic line plot, so it will be displayed as a title on the. So like you said, see, like you can see it, this is the title. And if I wanted to specify x label, like I just used x-axis only. But if you wanted to name anything, like for example, if I wanted to name ABC, something like that, it could be, then it will come as ABC x-axis. So you can name whatever you want, or whatever as per your data, or whatever the requirement you have, you can name the x-axis something like that. So since I'm just using x-axis only. And similarly, if I wanted to name the y-axis plt dot y label, then I just wanted to show the plot, then plt dot show. So this is my basic line chart by using the above syntaxes. So see, the line started from 0, since the starting point of x is 0 and y sine was 0, because y is equal to np dot sine x, sine 0 is 0. So that is why graph started here. Then it goes on. So when my x-axis x values are increasing from 0 to 10, then it is passing to np dot sine. Then the graph will be generated according to the values. So this is how it got generated. So you can see sine value is 1 here, and my x-axis value is something near to 2 or 1 point something, though that is where my y value is 1, then it is decreasing, then increasing. So this is how you can plot a basic line chart by using x and y variables. So actually I have created entire file, but I don't know, somehow it got crashed. So the use case, when do we use this line chart? So showing trends over time or a sequence, comparing multiple time series. So the best example is like if I wanted to look at a stock price based on the time. For example, if I wanted to look at the Google stock price, so it will be represented in a line chart only based on the time, like for last 5 days or last 10 days, last 1 year, last 1 month, or last 5 years, something like that. So we can represent whenever we are working on any trends over the time. So that is the use case. So that is for a basic line chart. Now we are going to talk about subplots. So we are done with this normal charts. Now I just wanted to explain this subplot. I wanted to, because whenever I'm working on this visualization part, I wanted to create some subplots. So this is how you can create. So this is the syntax for creating a subplot is like a figure and axis. This will create the access, because subplots are like you need to give the access details also, where I wanted to create the subplots. So here I want a 2 by 2 subplots, which is like a normal matrix, 2 by 2 matrix. I wanted like this. These are the positions of the subplot. So this is how you can give the syntaxes. The part of the code unpacks the tuple returned by a plt dot subplot, so into two variables. And so same thing, I'm giving x is equal to np dot linspace. Similarly, same, I wanted 100 numbers from 0 to 10, and I wanted y is equal to a sign. Then I am specifying axis 0000. I wanted I wanted to plot this x and y by using x and y what parameters, and I'm just setting the title as PLT1 first graph. Out of four subplots, I'm going to name the first plot as plot 1. Similarly, 0, 1. So basically, it is, if it is a 0, a 0, something like that. The first place or second place, and the third place, and a fourth one. So I want subplots like this. So where I want a one subplot here, and I want a subplot here, then here. So I'm going to specify. So it is a 0, 0, 0 position. Here I wanted plot 1 by passing x and y, and I want this is a plot 1, and this is a plot 2, plot 3, plot 4. So I'm just according to that, I have to set the title of the subplots. So if I run this, and let me see, am I able to see? And here you can see that normally in the plot 1, I just give only normal x and y. This is like a above graph. And but whereas in the second plot, I wanted cosine. First time sine wave, second time I want cosine wave. So that is why I specified my, this time my y variable got changed to np dot cosine, and third time tan, then last time negative sine wave. So this is my requirement. This time I wanted to plot four subplots by using this subplot method. So this is the result. The plot one is a normal sine wave, and the second plot is like a cosine wave. This is a tan wave, and this is a negative sine wave. It is quite opposite to a first plot. See, this is increasing order. This is, whereas this is decreasing, then increasing. This is increasing, then decreasing. So this is how, if you wanted to create any subplot, so use this syntax. We need to specify the axis first. PLT dot subplot. The syntax is PLT dot subplot. Then you need to specify the axis. So this is about subplots. And if I wanted to do some customization, like I wanted to coloring, or I wanted to mention something like that, so we can do that as well by. So this time using same, I'm using the same x variable is like 0 to 10, 10, 100 intervals I wanted. Then I am giving y1. Now this time I'm using two y variables, sine and cosine for y2. Same, I wanted to plot x comma y1, and this time I'm giving a label name is equal to sine. And second, for the label name I'm giving is cosine. Title is giving sine and cosine waves, and x label is x-axis, y label is y-axis, and a legend and plt dot show. So this is how you can like with by using legends. So here, whereas in the first normal simple graph, here the legends are not showing, like for what kind of a graph this is. If I wanted to specify the legends, so you need to mention that as well. So here the labels, The label is sine wave and cos wave. So according to the color, so this blue color is for sine wave, so that is why it is showing like this, and this orange one is like a cosine wave. So this is how, if I wanted to label the mention the labels, you need to pass this label is equal to sine wave. So it could be anything, like since it is a sine wave, I'm using sine wave. If you wanted to name as per your requirement, just pass that name here. First, you need to pass the variables, then label is equal to the required name, what the graph is for. So that is how you can name or you can mention the labels by using the legend method. So that is for customization. And if I wanted to plot a bar graph, so just now we completed with a line chart, basic line chart, and also subgraphs or subplots of line chart, and also customization. If I wanted to show the labels and also the legends, so this is how we can do it. And now we are going to discuss about a bar chart. So bar chart is like whenever we have any categorical data. So here I have a categories of data. For example, I have data. So I mean, I'm talking about example use case. So for example, I have four regions: south, north, west, east. I wanted to know the sales from each region. So I have sales data for four regions and I wanted to look at it, which region is performing better. So in these kind of scenarios, the bar plot is suitable. Like it will give me a clear cut information by categorically. So this is an example where I have categories A, B, C, D, and I just passed a list of numbers corresponding. A is equal to 10, B is equal to 24, C is 36, and D is 40, something like that. Now this time, if I wanted to plot a bar chart, the syntax is like plt dot bar. We need to specify the bar chart. Whereas if you specify normal plt dot plot, that will by default it will take as a line chart. See, we did not specify just plt dot plot only. We are just using plt dot plot. So PLD dot plot syntax is to generate a line chart. And if I wanted to generate a bar chart, I need to specify PLT dot bar chart. Then I need to pass the variables. Now I wanted to plot a bar chart for categorical variables X. I wanted categories on X side and values on a Y side. So this is first position is for X axis and the second position is for Y axis. So PLD dot bar and the categories and values, and I'm going to title. This part is same for all the graphs. If I wanted to name the title, then I need to pass PLD dot title. I am giving a bar plot, something like that. Then my X axis label I'm giving is categories and Y axis label I'm giving values. Then PLT dot show, then it will give me a bar chart based on the above data. So this is my bar chart for above categories and values. See, for by looking at these categories and values, it is like, okay, we can able to understand for the simple data. But what if I have a very large data set for regions? Like I said, one example for regions, I'm not able to, I mean, understand which region is performing better. So if I wanted to plot a bar chart for categorically, so here you can see that, see for A, B, C, D, out of four, if I take consider these are the sales values, so I can easily say that the region D sales are very good and the region A is performing very poorly. So that is the use of this showing the data in visually. So this is for a bar chart. And next thing is like, so this is what the use case. So as I explained, so these are all the use cases for whenever we wanted to use comparing quantities of different categories, and also displaying categorical data, sales per product category and population per country. So this is again a categorical population I wanted for different country, then the population is like that. We can able to display whenever we have these kind of datas. And the next thing is like, I want a histogram. So This is my histogram, and first we'll talk about the use case of the histograms. So whenever if I wanted to display the distribution of a single continuous variable, and in those scenarios we will use this. Basically, histograms will give me a distribution of how the data will be distributed. Here you can see it is almost like a bell curve. The data distributed more on at zero, then negative side and positive side the data values are more. Then if I see at the -3 and minus +3 wise, there is no data present. So how the data presented or how the data distributed. So in these use cases we can use this histogram, understanding the frequency of a different range of values. So here I can able to see how many zero values are there. 80. So first let me explain the data first. Now I'm my data this time I wanted a random distribution of numbers. 100 integers. This is np.random will generate random numbers, and rand n is like a normal distribution. It will distribute it 100. I mean, this syntax will give me randomly 1,000 numbers how distributed. And this time I'm giving, so you need to pass plt dot hist because I wanted a histogram, and plt dot hist. Now I should pass the data and number of bins I wanted. So here I wanted, I mentioned 30. So that is the reason why you can see 30 bins are generated here. So 1, 2, 3, 4, 5, 5 in each cell. So 30 bins got generated. So this part is again same title, X label, Y label, and show. So whenever if I wanted to see the distribution of the data, so the histograms are very good. You can able to see how the data distributed, how and the frequency of different range of values, distribution of ages in population, and distribution of test scores. So these are the use cases for histogram. And and I'm going to talk about a scatter plot. Scatter plot is like, again, if I wanted to show or if I wanted to see some relation between two variables. I have x and y variables. I wanted to see how the data distributed between x and y, and we can able to identify some patterns, correlations, or outliers. So basically, if I am working on machine learning algorithms, I wanted to see the correlation between output variable or a target variable and the features. Then this will give me a nice idea. When the scatter plot give me the correlation is nothing but if there is any increase in the x value, is there any increase or decreasing in the y value. So if I am increasing, or if my x values are increasing, and what how the y values are changing, is it in a increasing order or is it in a decreasing manner, or if it is increasing positively or negatively, how it got correlated, positive correlation or negative correlation. So something like that we can see with the scatter plot data distribution. So showing the relationship between two variables, and we can able to see the patterns where the data, how the patterns are there. Here I wanted again the random 100 numbers on x and random 100 numbers on y level, and this time I have to use plt dot scatter, and I'm passing the variables x and y. Title, x label, and y label I'm giving the same. So since I passed np.random, if I run this code again, this graph will be, I mean, you will get a different graph, because this time it will take different random numbers. See, if I run each time, yeah, I will get a different plots. So this is how you can see, if I wanted to look at the relation or correlation between the two variables, then I have to use this scatter plot. If I wanted to look at any correlation between, especially when I'm working on a machine learning algorithms, if I wanted to look at the correlation between features and target variables, so it will give me a nice idea, scatter plot. So that is about a scatter plot. And pie chart. So now if I wanted to, when do I use a pie chart? I have a data showing a proportion of like percentage distributions. For example, I have sales, like I said earlier, I have a sales data for 4 or 5 regions. Then I wanted to show in a percentage wise. So this is a best suit for this kind of data or this kind of problem statements, market share of the different companies. For example, if I take Apple, Google, Microsoft, or Tesla, something like that, if I wanted to see the market share of different countries, different companies, so this will be a best uh, plot and budget allocation, something like that. If I wanted to see like how much percent the each category is contributing, so this is a very good chart, pie chart. So I'm just passing 4 labels, A, B, C, D, and also the size of the 4 labels. This time plt.py because I wanted to show a pie chart, and I'm passing this values sizes. Then the labels is equal to labels because I'm my labels are A, B, C, D. So that is the reason why I passed labels is equal labels. So auto PCT is like I wanted to get the percentage out of 100. How much percentage of these categories are there? So I want a up to 2 decimals. So that is the reason why one, then strangle is equal to 140. So strangle is nothing but optional parameter specify the starting angle of the pie chart, where the pie chart has started to generate the starting point of the pie chart. So that is optional. If you wanted to give, or else you can leave that parameter strangle. Then normal, again title I'm giving, and plt dot show I'm giving. So this is how if you can draw or you can plot a pie chart. This is for pie chart and 3D plots. Next is like if I wanted to draw a 3D chart. So basically, when do I use this 3D plots? Like 3D plots are very powerful tools for visualizing complex relationships and multi-variate data. If I have 3 variables, not two, x and x, y, z. So if I have 3 variables, I need to plot a relationship between the 3 variables. That is like again a 3D. So in those cases, we can plot a 3D diagram where I can able to see some relationship between uh, multivariate data. So here I wanted plotting this figure plt dot figure, and axis I'm giving plt dot add subplots, and 3+1 projection I'm giving 3D because I wanted a 3D diagram, and my x variable is like np dot linspace -5 to 5 100. I want 100 intervals. Again y is np dot linspace same, and x comma y is equal to mesh grid. I wanted to show this as a mesh grid, and my third variable is z is equal to np dot sine np dot square root of x square plus y square. So if I have my anything something like that, x square plus y square, something like that, then you need to use this 3D plots so that we can able to see the relationship between this a x y z. So this is if I wanted to see some C map is equal to word is like a colors. So this is how you can see a 3D plot if you have any multiple variables, 3 variables. If I wanted to project my data in a 3D, then you can use the syntax. And next is if I wanted to do some styling part, or if I wanted to modify my plot, so we can do that as well by using the this syntaxes. So now the same basic line chart only, but this time I wanted a different color and with a grid. So now plt dot style use this time I'm giving ggplot something. It is an inbuilt graph. If you pass this ggplot, it will be the graph we are going to visualize. It will come in that ggplot style. So there are multiple styles, so you can do some research, and if you wanted to visualize your data in that particular style, you can pass that variable and we'll be able to show the data in that required style. So here the syntax is like plt dot style dot use, and you need to pass the kind of style you wanted. And this is again the same. X label is like same, Y label is passing X and Y labels, and plotting X and Y title part and the X label Y label. This is same, but you should pass the extra syntax is like plt dot style dot use. So let me show you this one thing. See, this is how you can able to see plt dot use matplot styling setting from a style specification. The style name of default reversed for reverting back to default. So this is how many parameters you wanted to pass. So this here you can see the description of the that syntax, something like that you can see. So this is how, if you wanted to use a different style, then you can use this plt dot style use. So that is if you wanted to customize or using a style sheets. This is how you can use a styles uh, and annotating plottings. I wanted to give some annotations, so that is also we can do by giving some annotations in the normal graphs. Excuse me one second. So here I just wanted to plot a normal line chart, np.linspace, same again. This time I'm passing a plt dot annotate. This will give me the now. So let me run and show you, then I can able to explain. So here you can see annotations, right? The x and y is equal to this, x and y text is equal to this, and arrow drop, something like that you can able to see. And also the arrow color is black color. I just created this this thing, the arrow which with the black color, and also the size of this arrow, everything I created with a plt dot annotate. So this is how you can create if you wanted to show something in your graph with annotated plot. So normal graph with some customizations. So this is for if you wanted to do some customizations in your a line chart. Normal, it will work on all the kind of charts like bar chart, pie chart. You can annotate with the required conditions. So another thing is like I have a data, and if I wanted to work on a data, let me see this graph. So now I have this data with some dates. So I my dates are like pt dot date range from 1/1/2023. I wanted 100 periods for starting from 1/1/2023. See, when I'm working on this data, so now this plt dot figure, it will give me if I wanted to specify the x-axis value and the y-axis value. Like I wanted figure size is equal to 12 comma 6, means I wanted 12 centimeters x-axis and 6 centimeters y-axis. So if I wanted to 10 by 10 also, we can do it. We can change it 10 by 5, something like that. Then it get adjusted as per the, and plt dot plot. This time I'm passing dates comma data, because I wanted dates on x-axis and my data will be on y-axis, x and y. Then plot title x label, y label, these are the same things. So when I'm working on data, I have time to time data, normally stock prices. So I wanted to know the stock price on day on day, and this my stock price. So this is how you can do it by if you are working on a data with some dates, basic normal line chart, but time data. with the time to time how it got varied, how it is varied, something like that. You can do this as well. And also if I wanted to save my chart, I created a line chart and sorry, some chart, it could be anything, and I wanted to save it. So that is also we can do it by passing some syntax, something like that. So this is my normal line chart, x np dot linspace 0 to 10, 100 intervals I wanted. Then my y variable, I am just plotting a normal mm, line chart, and I wanted to save this chart somewhere. So plt dot save pig, it will save the, it will going to save this printed, this graph in my uh, repository, in my, in like Jupyter, or it will be saved, it will be saved in the required folders. Since I'm using Jupyter Notebook, it will be saved in my Jupyter Notebook only. So that is how you, if you pass save.pig, then it will save the visualized graphs. That is for if you wanted to save the some data. And there are some more customizing tricks. If I wanted to see my graphs in some more customized manner, then we can also do it. Okay, so the same normal line chart, but this time I wanted this, I wanted to replace my 0, 2, 4, 6, 8, 10 with ABCD. So I wanted to replace existing data with a new data, or I wanted to remove my older data and I wanted to replace that old data with a new data. So plt.xticks, it will be replaced with a b c d e f, the replaced new value, and y, it got replaced with some categoricals, low, medium, high, something like that. So yticks, plt.xticks and plt.yticks, I wanted to replace old values with the new values. I can also do that by using this xticks and yticks. Other than that, all are same again. This is how you can do some customizations also. And if I wanted to see the grid, the background, that is also we can able to achieve. Here the grid I am giving you true. That means the background grid, I can able to see some grid, right, with some squares. So if I pass false here, then it will be a blank space. I will not get any grid. I just got this some graph without any grid. But if I wanted to, if I want that grid, then pass plt dot grid, then pa pass the true value. I wanted grid true. Then it will give me same normal code, extra plt dot grid. It will give me a grid. That is for if you wanted to grid, or if you wanted to remove the grid also, plt dot grid, pass true or false, however you wanted. And this is for histograms with some customization. Previously, we also discussed about histograms, right? Whenever if I wanted to see the distribution and frequency of the numbers, I can able to plot, or I have to use the histograms. If I wanted to do some customizations on histograms, so here normal random, again I'm using my data is like I just wanted to get a sample distribution of 1,000 numbers, and this time I'm indicating bins and alpha is equal to 0.7 I'm giving, and color also I'm giving. Edge color I wanted a black color edges. See, all the bars are, edge colors are like black colors. So if I pass black here, then the edge colors will become black. Then title, I'm, this is same X label Y label title, and grid also I'm showing this. And this is how you can do some customization. If you wanted like this edge colors, then you can pass by using this syntaxes. So that is one thing. uh, Box plot, so this is also a very useful plot whenever we are working on any machine learning algorithms, and if we wanted to see some outliers, then box plot will help me to look at the data with some outliers. And let me plot a basic box plot. So this time I just wanted random integers, 10 integers with a space 5 5. So 1 2 3 4 5, and that is my data, and plt dot blocks plot, I'm just passing this data. And so here the use case of this box plot is like, so whenever we are working on this entire quartile range IQR, and I wanted to see some outliers which are present, then we can able to see this is a outlier, something like that. So if I wanted to look at my data with some outliers, then I can use this box plot. So this is the syntax, plt dot box plot. Then I need to pass the data, and I need to specify the title, x label, y label part are again same. That is for box plot. And the use cases, as I said, we can use this box plot summarizing the distribution of the data set, identifying outliers, and spread of the data, how the data got spread. And distribution of examples are like distribution of salaries and comparing distribution across different groups. So that is where we can use. And the next thing is like error bars. So I need to show some error bars in my graph, then I can use this error bars. So here normal line chart only by using the same syntax, linspace, and my variable is also np dot sine wave, and I'm giving y error, np dot random uniform 0.1 to 0.3 size is equal to y dot shape. So this is, I'm giving this error, y error. Y error is nothing but the error values for the y coordinates. These values determine the length of the error bars above and below each data point. Above and below data points. This is, if my data point is this will be my y error above and below the data point. So, and plt dot error bar x comma y comma, and also I'm passing this yerr is equal to yerr, and fmt is equal to this specify the format of the plot line, then indicates a solid line connecting the data points, a solid line connecting all the data points. So these are my data points as per my x and y, and connecting all these data points with a line, with a solid line connecting data points, and this zero specifies that the data point should be marked with a circle. So all my data points should be marked with circle. That is why I'm indicating this fmt is equal to dash with a circle. That is why my data points are filled with dot and circle. This is again same title, x label, y label, and show. So this is how you can, if you wanted to see some error bars, then we can do that by using this syntax. And the use cases of this error bars is like dis displaying variability or uncertainty in the data, or representing confidence intervals or standard deviations. So I'm gonna talk about all the statistical words like mean, median, standard deviation, range, variance in coming videos. But if I wanted to see some standard deviation intervals, then I can able to see by plotting this error bars. And next plot is like exponential or logarithmic scale. Okay, so my x-axis is zero point 0.1 np dot linspace 0.1 to 10. I wanted 100 intervals. Then I'm giving a y label is like np dot exponential of x. So exponential of x is like this curve with a exponential manner, increasing manner. So this is again plt dot plot x comma y scale is equal to, I'm giving a log, title, x label, y label, and the show. So this is how you, if you wanted, if you have anything in exponential function, then you can use this function. and multiple y-axis. So if I have multiple y-axis, I have only one x-axis and I have multiple y-axis more than one. We can also plot a graph something like that also with a multiple y variables. Or so here my x variable is like np dot linspace 0 to 10, and my y1 I wanted a sine and also a exponential x by 10, sine of x and exponential of x by 10. I wanted two y variables. Then axis 1 I need to pass, because this again comes under subplots. So I need to specify the axis, and plt dot subplots I'm giving, and x is equal to y is equal to and y2. I need to specify the different variables, three variables, since I'm using two y axes. And the plot one, ax1 plot x comma y comma. So why I'm giving passing this, because I wanted a green line, a green straight line. So g dash will give me a green color line, and I'm setting the labels as x-axis, and y label is like sin x, and color is green. G means green. Similarly for the second line, ax1 twin x and plot x comma y2 comma. This time I wanted a blue color line, blue line. Then I'm setting the y labels color blue. So and the title and show is same. So that is why if I pass G, the plot is generated with a respective color. So if I pass B here, you can see blue color. If I pass O, so you can see orange. If I pass W, a white line. So if you wanted how the graph or how the line you wanted, you can pass that line. So since it looks good in green color, then let me pass the same variable. So this is how, if you wanted multiple y labels and only single x label, then you can use this syntax by using this subplots, plt dot subplots. That is how we can achieve. And the next one is like polar plots. Polar plots are nothing but uh, whenever I have a data, uh, like plotting data in polar coordinates representing cyclic data such as angles or periodic functions. So if I have my data in some angles, or with the angles, if I wanted to represent it, so 360, the polar 0 45, how the data varies with some angles 90, 135, 182, something like that. If I have my data in angles, then our periodic functions, then I'll be able to look at the data by using this polar plots. So here I'm specifying a variable called theta, np dot linspace. This time I'm giving 0 to 2 pi. 2 pi is nothing but a 360 degree. 0 to 360. 0, then again it will 360 here only. 2 pi, 2 into np dot pi, and 100 intervals I wanted. np dot abs uh, sine theta, or I wanted the radius. I wanted, this is called the radius from center to the edge of the circle is the center. np dot linspace 0 to pi generate a 100 evenly spaced values between 0 to 2 pi. So 0, 45, 90, 135, 180, nothing but a pi. Then again increasing and 2 pi, and approximately 6.2, and these values represent angles in radius. Sine dot np dot sine theta computes the sine of each value in theta. So this is the theta value, and I'm passing this theta to a sine values between -1 and 1. np dot abs, np dot abs, np dot sine theta takes the absolute values of the sine values, ensuring all radii or and non-negative. So this is useful for creating a visually appealing polar plots. So if you have any data in a angles or a periodic function, then we can able to look at the data by using this polar charts. Plt.polar, you need to pass a variable theta and r, then you will be able to get the data in polar. That is one thing that is for polar charts. And heat map. This is again a very useful graph whenever we are working on machine learning algorithms. So this is a heat map. Heat map, I'm giving, I wanted a data, random data from 10 by 10 uh, figure. This will generate a 10 by 10 array of random numbers between 0 to 1. So random integers, I wanted random integers in between 0 and 1. These values will be used to create a heat map. So 10 by 10 heat map, this is 10 and 10, 10 by 10 heat map, and the values are vary from 0 to 1. Plt dot ims show and data, comma, c map is equal to hot and interpolation is equal to nearest. So I'm passing this. So this plt dot im show data, this function displays the data as an image. So if I use this plt dot ims im show, it will create a image that is a 2D regular raster. And CMap is equal to hot. This sets the color map to hot. The hot color map varies from black to yellow, and yellow to white. Black to yellow to white. It corresponding to increasing the data values. If the data values are increasing, then the color will be varied. The choice of color map is significantly affect the readability and interpretation of the heat map. The interpolation, here I mentioned interpolation is equal to nearest, right? This sets the interpolation method to nearest. It means that the color of each pixel is determined by the nearest data point, which creates a blocky pixelated look. This is often used when displaying heat maps to keep each cell distinct and clear. So this is how you can create a PLD dot title I'm giving. And this is how you can look at the data, how it got distributed. So So this is from 0 to 8 again, and 0 to 8. So 0 being black color and point to 0 to 1 I wanted, right? So 1 being a white color. So this means entire block means a 0 value, and if I have any red colors, it is like a point 0.4, and if it is like something yellowish, then it is like point 0.7, something like that. So this is how you can plot a nice heat maps. And the next one is like representing counter plots. So basically the counter plots are versatile tools for visualizing relationship between two continuous variables in a data set. By representing equal values of one variable with the counter lines, these plots provide insights into the structure, pattern, and gradients of multivariance data. They are commonly used in various fields, like including geospatial analysis and environmental science, and also engineering and optimization to explore, analyze, and interpret complex data sets. So whenever if I wanted to look at two continuous variables, then I can able to use, see, my x variable is like np dot linspace minus 5 to 500 intervals. Same again, my y, x comma y is equal to np dot mesh grid. I'm specifying the grid as mesh grid x comma y. And the third variable z is equal to np dot sine, np dot square root of x square plus y square. It is nothing but a 3D. And pld dot counter x comma y comma z, then this is how it looks whenever two continuous variables, x and y. So that is one thing. And last is like whenever if I wanted to integrate with the pandas. We already, I mean, I have explained this thing, but integration with Panda. So I have a data in a data frame, my data from date range, like same as explained earlier, from 1/1/2023 to I wanted 100 intervals, 100 dates, and pd dot data frame. NP, I wanted to create the data frame from these dates. NP dot random dates index is equal to dates, because my indexed values I wanted dates in index, and columns is equal to list. I'm passing a list is ABCD, and data dot plot, which will plot the line chart for this data, and this is again same time to time from 1/1/2023 to it will give me 100 intervals, 100 dates, 100 periods from 1/1/2023 to it will generate me 100 days data, like till April and something like that. And also I'm specifying with this indexes dates, and also a column list I'm giving the color, a red being red, blue colors, and something like that. So whenever we are working on pandas data frame, so we can also able to plot directly with the data dot plot. It will give me a line chart with that particular data. So this is about this visualization tool, Matplot library. I hope you guys are able to get something out of this video, because we just started with a basic line chart with by passing two x and y variables, and we also covered how to create a subplot, and how to do some customizations with by using two different y-axis and one x-axis. And by working on a categorical data, we can also use this bar charts and histograms whenever we wanted to look at the frequency distributions, and scatter plots whenever we wanted to see the data distribution, and pie chart whenever we have any uh, like if I wanted to look at proportionate data, or visualizing percentage distribution category wise. 3D plots are like if I wanted to visualize the relationship between multivariants like x and y, z, something like that. And if I wanted to customize my styles, I can use plt.style. And if I wanted to annotate something, like specifying or showing something on the graph, I can also do that by annotating. And like if I wanted to draw a line chart with the dates on time to time, like example stock price. And if I wanted to save the created plot, I have to use save.pig. And some more customizing ticks, like I wanted to replace the older values with the new values on x-axis x ticks, y-axis y ticks. So we can also achieve that. And if I wanted to see or delete the grids, and if I wanted to see the frequency distribution by do some customizations, colors, edge colors, something like that. And how to create a box plot and use cases of the box plot. So this is how we covered all the things. I hope it will be helpful for someone who is looking for these kind of basic things. So I hope you guys are liking and getting something out of these kind of topics. So please do subscribe the channel. And that's it for today, guys. Bye.